Hi, Bob here with JD Squared. Thanks for tuning in. As you can tell, I'm on a live factory floor. In fact, they're actually making these parts behind me. We use our wedge cut system, let me move over, you can see it good, to make the legs that go onto the XR6, XR12, stuff like that. But anyway, I want to go ahead and take this opportunity to answer a couple questions that a previous customer who got their XR6 a few weeks ago had asked. And what had happened is two things they wanted to know. The lady that's working there generating the CAD files for the program, she just wanted to know, is there an easy way to just put a piece of tube in the machine and cut off at it, getting really dirty here, cut it off at an angle or square or whatever. So currently there's not the easiest way to do it. We're going to be adding that here very shortly, but I will be going back showing you in Camelot how to quickly do that. It's easy, but it's not as easy as it's going to be. And then what we're going to be doing is we're going to be adding wizards to the XR machines to where you basically pop a wizard up and say, I want to cut this square or rectangular tubing, and you tell it the angle. The reason we haven't done it yet is to calculate that angle coming across this curve is a little math intensive. So I've got to do that. Now we've already added the wizard to it that will actually cut off a round pipe. You just put any pipe in it, tell it the diameter of the pipe, and the machine will auto cut it off so that you don't have to go to Camelot and generate a program. Now we did that one because as soon as I come out with the tilt head attachment for the XRs, the manual tilt head, which will be probably maybe before FabTech, November 6th. What's the day? Like October 7th or something like that, 2022 by the way. So we'll be bringing that out. And the idea of that routine was if you want to bevel the end of a pipe, like for welding, you just manually move tilt the head and then run that routine and you cut off your pipe. I'll probably be giving that manual adjustment attachment to everybody who bought the XR6, XR12. Probably just get to them for free. That way some people can tell me how it works. You know, it's not that hard to make. Anyway, I will be doing that here in a minute, going back in Camelot and showing you. The other thing that they brought up to me was they mentioned that the XR6 was cutting the parts short, 1/8 inch too short. And I think that's what they said, 1/8 inch. And they said, oh, we corrected the length we made the part shorter. And I'm going, no, don't do that, don't do that. It's actually cutting the parts right. And it occurred to me that I've never really explained what normalization is well enough. And if you look at the machine cutting back there, you can tell the torch is vertical, straight up or down, right? So when it's cutting this cut here, it's going to be cutting straight up and down. It's not going to be angled this way with the cut. That's coming next year on our XRs, but it's not there yet. So anyway, what happens, it tilts this way. Well, when you make a cut, you want it to fit flush against whatever you're putting it up to, which means we're going to prioritize the ID of the cut. So when you normalize it, you don't cut on the outside edge out here, you reference off the inside. That makes your parts shorter. So the only way to truly tell if this part is the correct length would be to check the backside or to check down through the middle of it, right from here to here. Those numbers will be correct because when they're cutting this way, the torch is vertical, everything works out good. So I'll show you that a little bit better back there too. But in the meantime, let me go back there to Camelot, show Macy's her name, real sweet lady. Let me show her and you how to quickly generate a program to cut off square rectangular tubing, at least until I get a chance to write the wizard. All right, let's head on back there and get after this. Okay, I made it back to my office, and while I was walking back here, it occurred to me that we get questions every once in a while that people are importing a step file and they're having trouble. Camelot doesn't understand the shape or something else. Now, that could occur generally under three circumstances. One, the person created the part that when it's exported as a step file, Camelot cannot figure out what it is. And that happens when a newbie, and I was one of them, will create a part
generally the most complicated way you could do it because they're not familiar with their craft yet and they don't know the proper way of doing it. Well, you could piece things together in a CAD program that looks perfectly normal to your eyes, but when another program tries to dissect that, all it comes up with is a bunch of individual little pieces and surfaces. So that's a problem. Now, the other problem with step files is, of course, if the program that is generating the step files isn't putting out a good file, then Camelot won't be able to read that either. That happened to us with a customer, I think he's out of Canada, and he was using a program, and the program just put out a terrible step file. Camelot had no idea what it was. Now, it wasn't the company's fault. They're smart people. So we found out, we looked at a step file and said, this isn't going to work. So he contacted a company and they go, oh, all we got to do is make a couple setting changes and it'll work fine. So they did, everything worked flawlessly. So one of the things you want to do is if you're importing a step file and you're having trouble with Camelot, like Camelot doesn't understand what it is, then use another CAD/CAM program, import that step file into it and start looking at the edges and see if they make sense. Generally, you'll see a problem real quick. But the solution to get around that is just to create the part properly in the first place. And I'm going to go ahead and show you how to do that. I wasn't going to show you this, but I thought, you know what the hell? You know, you got a fast forward button on your YouTube channel, whatever. But so I'm going to go ahead and show you the proper way to create a tube or whatever and sweep it, like if you were going to bend it, so that if you brought it into Camelot, Camelot is instantly going to know what you're dealing with. Now, this doesn't matter if we're talking about Inventor, which is my CAD program of choice, or SolidWorks or Creo or any of the other ones. Fusion 360 is probably my favorite and the program I recommend the most under $2,000. If I had to do my job and you said, Bob, you can only spend $2,000 a year on a software, I'm going to go Fusion 360. I pay about $27.50 for Inventor and I get a lot of pretty cool stuff with it. I think SolidWorks about that area. But anyway, let's go ahead and create this part. I think I'm babbling a little bit, but that's according to my wife, that's what I do. All right, let's go ahead. I'm not going to teach you how to run a CAM program. I'm just going to show you how to create that square tube. All right, so we're going to create a square. Let's make the sides even. We're going to go ahead and dimension it at 4 inches because we are doing a 4x4. Now I need to go ahead and fillet the sides. They're 1/4 inch, so let's change that to 1/4 inch. 1, 2, 3, and 4. That's the outside of our tube right there, and I already screwed up because I just noticed I didn't minimize myself. Well, I'm starting over. So let's go ahead and shrink this ugly dude down. All right, let's continue. Sorry about that. All right, now what I've got to do now is I've got to offset this path right here in a little bit. And we know that we have a wall thickness of 1/8 of an inch. So that is our profile right there. Now we could extrude this profile out and accomplish what we want to do. But before I do that, let me show you the proper way to sweep a profile. Let's say, for instance, it has bends in it. So what I'm going to do is I'm going to go ahead and we're going to create a new sketch. Let's draw this line here to here. We're going to go up. We're going to put a bend in it for giggles. And then we're going to go up. Okay, we'll say okay. I'm going to say that these two ends are equal. And anything I'm doing right here, there's no rhyme or reason. I'm just making a part. Let's go pull this out and let's dimension this. We'll say 6 inches. We just need a number. Okay, there you go. There's how you would create the sweep and the profile and the sweep. So if I go up here to sweep, it's asking me for the profile. I'm going to click that. Now it wants to know the path. I'll click that one. Okay, that's your part. That is the only way I will create a part to head out there to cut on the machine, because Camelot will understand exactly what this part is. Now, let's go ahead and unsweep this thing right here. And I do not want to get rid of my consume. And I'm going to go ahead and delete this sketch. We don't need it no more. Now, I'm going to go ahead and modify this sketch and show you what could happen. We're going to draw a line from here to here. We're going to say finish. Now, let's go ahead and extrude this out. Let me zip it up here. And we're going to extrude it out right there. And we'll say, okay. Now, you can come along and mirror this and create a square look. In fact, I'll show you how to do it. So if I was to say features this, and then as far as a mirror plane, I'm going to select this right here. That's going to be your square tube. You think everything's okay. Well, depends on how the step file's put out. What happens if the step file doesn't know that when you mirrored it, you wanted a single solid, but instead you forgot to tell it was a single solid, it put out two halves. Camelot will not see that as a square. It's going to see it as two halves. Therefore, it has no idea what to do with it. So that's why you want to create your geometry or your parts the way I just showed you. Like I said, I'm trying to cover a lot of bases in this video. As my mind's racing right now. What questions have I been asked recently? So anyway, that's our part right there. We're going to go ahead, modify our extrusion so that we are picking up the solid part, and we're going to make it 10 inches long. You know, doesn't matter the length, by the way. All right, so that's our tube right there. Now what we need to do is we're going to cut this tube off. Now, I think I mentioned it. I'll say it again in case I didn't. This is how Macy, that's the lady who asked about this, could create a part if she had her own CAD/CAM program. She deals with detailing. They make stairs and everything like that, details and all. So she's not going to have their software because their software is probably pretty expensive. But let's just say if she went out and got Fusion 360 for $500 a year or something like that, she can now create all kinds of parts, do things herself, do it this way. I'm going to show you two different ways of doing it. So let's go ahead and cut through our tubing. We'll say, okay, there's our part right there. Now, I can take this part and save it as a step file, like right here. Let's go to export as CAD format. Now I need to tell it it's a step file, and then I can go ahead and tell it what that part is. So if I go to my, where did it go? Let's get out of products. Let's go to code, go to Guido, go to test pieces. I could save that right there as a cut file because it's a step file, bring it into Camelot, process it, go out there and cut. That's one way of doing it. The other way of doing it, of course, is to use Camelot to do it. I'm going to show you both ways. This way right here is just happens to be the first one I picked. All right, so that's our part. We could head out there and cut it, and let's just say you wanted a slightly different angle. You've got this part already. Just go ahead and make it 30 degrees. Bam. Save it as a step file. Load it into Camelot, process it, take the G-code, and go out there and cut. That's how you would do it. Now, let me show you real quick a little bit what normalization is before we continue on with Camelot, and where you could accidentally think your part was too short. So we need to go ahead and need to create a plane. We're going to pick this face. We're going to pick that. That's our plane. We're going to say OK. Now, I need to go ahead and create me a new sketch on this plane. Let's zip over here. By the way, all CAD programs work extremely similar. So if you're using SolidWorks, Inventor, Fusion, they're all going to work basically like this. Now, I'm not mentioning all this. I don't have to. You'll see why in a minute. I want to go ahead and cut that face that away and hide the work plane real quick. That is a normalized surface right there. So let's click it right there. See how it's straight up and down now, and that's because the torch is straight up or down. Now, when we cut this part, what we care about, if I can get this vertical, we care about it mating to a surface here like a flat surface. So we want to prioritize this inside edge. Now, when Camelot normalizes everything, it's also going to normalize this side. I'm not going to show you how to do that. It's a little more complicated because you don't only normalize this face, you have to normalize the roundup around the rest of the bend. And that, by the way, is why I haven't done it yet on like a wizard that I'm going to put into the program. Hell, I'll show you the problem. Let's create another plane. We'll do that right there. We'll say, okay, we're going to do the exact thing I just did a minute ago. I'm not justifying my laziness, by the way. I'm just kind of showing you that it's going to take a little bit more time for me to do this. Right now, we got a whole bunch of people who want their XR12s, and that's kind of what I've been concentrating on real hard. So if we do this right here, and we do the exact same thing, we cut it out, we go like that. Okay, let's hide that work plane also. And there you, and did I do it? Okay, I did something wrong. What did I do wrong? Oh, I cut the wrong way. Let's flip that the other direction. There we go. All right. There you go. Okay, you see the normalized cut right there, because remember the torch has got to come in. Let me see if I can get it to show you better. It's got to come in vertical. Well, when I go to write that code to normalize this, I've got to figure out all the math to normalize this section right here. And I haven't started on that yet, but I will be adding this wizard to the machine here in the next, I don't know, before the end of the year. I think it's going to take me a few days to write this, and then you won't have to do this anymore. You just go with the machine, you'll fire the wizard up, give it the dimensions, tell it what angle you want, it'll cut it out. But that's for the future. All right, let's go ahead and that's what I was going to show you, the problem measuring. Now, if we go ahead and I'm going to do what's called, I'm going to create another thing right here. And this one right here, we're going to call not normal. How about that? Kind of like me, I guess. All right, not normal. Now, if that means we haven't normalized anything, so we're going to go ahead and suppress these parts right here. I think if it ever lets me suppress it. Come on. Let's see. Let's suppress that one. And then we're going to suppress this one also. Okay, that's our non-normalized part. And if we click here, that's normalized. So let's go ahead back to the non-normalized part and measure from here to here. We get 10 inches. Now, let's go ahead and go back to the normalized one, do the exact same thing, measure it. Now we're going to get 9.9275. It's kind of a weird number. Oh, that's right. I changed it to 30 degrees. If we were 45 degrees, it would have been an 1/8 inch, just the way it is. But it's that, so you can tell that it's not 10 inches long. It's going to be wrong. However, regardless of which way, normalized or whatever, if I had checked from the middle of the tubing to this edge right down, it's always going to be that length no matter what I do. So keep that in mind, that if you measure your part and it's a little short, it most likely because you're measuring on a normalized surface and it will be short. Now later next year when the tilt heads come out, they're gonna be able to rotate that torch at an angle to cut that, and you'll actually have the right lengths, but that's coming out next year. All right, anyway, let's go ahead and export this as a step file, and that brings up another thing. I do not export my parts as a normalized part. I don't go to this trouble because Camelot is going to do it for you. It's going to do it really, really well, so why do it right here? But I do need to export this part. First thing I want to do is I'm going to go back and I don't know, whoops, I'm sorry. I hit the wrong one. Sometimes I get going too fast. I'm going to go back to my 45-degree cut. Go like this right here, and I'm going to go to export CAD format as that's right, a step file. Let's bounce up to our code deal. Step files are the 3D format that everybody exchanges, them and IGES files. Now we are going to be supporting a new file. I'll tell you about it right now. My son has taken over development of Camelot because we no longer have the software developer that we worked with for all those years. And we are looking for another software developer. We pay extremely well. I mean, like, we looked it up. We pay better than Microsoft pays. So if you know anybody looking for a job with maybe a computer science degree or very well self-taught, very good math skills, has to understand 3D geometry and all, and they're looking for a good job with great benefits, tell them to give me a call because it would be beneficial for you. Because if we had more help writing software, I have a list, oh my God, it's so long of things that I want to add to Camelot. It's just not enough hours in the day. Anyway, so I exported that as a step file. Now all we got to do is bring that part into Camelot, head out to the machine and cut. So let me show you how to do that. I've got Camelot loaded up right here. What you see is a part that I'm currently working on today. And what it is, we've decided on the XR12s to widen the legs out 5 inches. So I have to create new legs. Now, we went out and we cut it, but the angle was not correct. It won't go all the way down. So I have to tweak the parameters, and then we do a test cut and we make the final part. And it occurred to me, heck, I'll show you guys how to do that, providing I have time today, because I'm leaving town tomorrow for a week. Wife wants to go to Disney World, therefore we're going to Disney World. And I thought, maybe I have enough time to where I could show you this. We'll see how it works out. If not, when I get back, I'll show you how to do it. Anyway, let's go ahead and continue what we're actually supposed to be doing. Let's bring in our step file. And that's it. Now it's asking me, do I want to, detect features? Yeah. And do I want to make a job? Sure, I'll do that too. Let's give it a second. There we go. All right. I'm going to save it as that 4x4 angle cut. We'll say okay. There we go. Now, if I click on this icon up here that puts it in view, and I click on the start cut, we've got the square side as a start cut. We don't want that. Now, the start cut is the one that's going to be farthest away from the chuck. The end cut is the last cut you're going to make on the end, and it's closest to the chuck. Well, the tube is flipped the wrong way. So what I need to do is go up here and reverse the tube. And now it's reversed. Now if I click on start layer, I'm there. Because we are not going to create code for the end. We only want to cut off the front right here. So to do that, I'm going to go ahead and get an operation, start cuts, make sure I've got the right consumable for what I'm cutting selected, set OK. Now if I click on it, let's come back over here. Come on. All right, if I click back on it and we rotate, zoom in, you could see the path has been offset. We're good to go, right? Everything is correct. So what I got to do now is close this tool out. I'm going to go ahead and nest it. Now nesting, generally you're going to select a length for your tube or tell it what you want. In this particular case, it makes no difference because we're only cutting the end of the tube. So I could put 20 inches, I could put 30 inches or 100 inches. It doesn't matter. The program will still run. Even if I told it it's 100 inches here and I loaded up a 20-inch piece at the machine, since this program is based off the end of the tubing, that's all it really knows. It doesn't really know. Camelot doesn't know how long the tube is. It just, hey, tell me where to start and I'll do my thing. So I'm going to pick 30 inches and there it is right there. Now, if I hit run post-processor, let's call that a 4x4. Ooh, I bet I could do angle cut. Let's get rid of the job extension. We definitely don't want that. And then we say save it. Now we could put this code on our USB, go out to the machine, load it up, and then run it. Now, one other thing I'm going to mention here real quick. This is a 4x4 piece of tubing, so it's even-sided. Let's say this was a 4x6 tube. Then what you're going to want to do is take note of where the lead-in is. And that'll tell you how to orientate it in the machine because you're going to have to use the wizard to square the tube. So what I like to do is when I get to the machine out there, let's just say, for instance, this was the 6-inch side and this was the 4-inch side. Well, obviously, you could put it in the XRs either this way or this way. So you got to know the right way. All you got to do is look at the lead-in. If you look at where it's going to start cutting and you know it's cutting it on the long side, now it'll show you a visual representation at the machine. That's how you would do that. I just thought I'd mention that real quick. I'm really trying to cover a lot of bases if I can here today. Anyway, Macy, that's how you would do it if you wanted to use a CAD program. Now, let me show you how I would do it in Camelot. I'm going to create a frame. We've got to give it a second. There you go. Now, when it comes up, we have to select the active profile. Now, I've already selected 4x4 with a an 1/8 inch wall. Let me show you where that's at. If I select active profile and I sort by height and I come down here, there's the 4x4 1/8 inch wall, and it's got over here, if you look, it's got a 1/4 inch radius. So Camelot knows what that is. Now, other videos will show you how to use the profile library, how to add structures to it, different pieces, stuff like that. So we're going to go ahead and make that active, and it's showing that it's active over here. In case you see the word false right here, all that means is that for that particular setting right here, let me pull it back up. If we go back to it, I'm just trying to teach as much as I can. The 4x4, it says it's got an achieved centerline radius of 4.5 inches, which means we had to have a bending die that's 4.5 inches. We don't have that die. So we did not click in stock, which means we would have that die. That's why Camelot right here is basically warning you that you're creating a part. If it's got a bend in it, you're not going to be able to make this part if you want to bend that tube. So that's what that means. All right, let's go ahead and we're going to add ourselves a tube right here. We're going to add a point. We're going to go this here, and we're going to go 10 inches. All righty. There's our tubing Camelot. So that was pretty easy, right? Now, if we want to go ahead and cut the end off, we're going to have to use grid functionality. So we go to the grid, we turn on our grid, and if you look at it right here, the grid's it's on the ground, right? That's, it's flat. Let me see if I could get you a better view of it. And let's zoom out a little bit. I'm trying to see if I could show you that grid. So you can see where it's not lined up. We need it lined up with the face of the tube. So what I'm going to do is I'm going to pick that one right there, plane X or plane YZ. Now the way you can figure out which plane to pick is look at the icon here in the lower left. It's got 3 arrows. Those are your 3 directions in 3-dimensional space. Z is up. X is towards us this way, and Y is to the right. So I just picked the YZ plane corresponding to the blue and the green, and that's right here, and that gave us this here. Now, one thing we need to do, though, is we're going to cut this at 45 degrees. So let's go ahead. I'm going to put in minus 45 degrees. Take a look at this first, see what it looks like. See, yep, that's the direction I want to go. I'm kind of trying to mimic what we did earlier. However, I have to offset this a little bit. Let's see if we're going the right direction here. Nope. I got to go minus 5 inches instead of 5 inches. Okay, there we go. So what I did is I basically moved the plane to where you could see it cutting through at a 45-degree angle right here through our tube. So let's go ahead now and actually cut the tube. I'm going to go back to tube, select cut tubes, not regular cut tubes, because when you cut tubes, it thinks you're going tube to tube. We want to cut tubes with a face. And I'm going to go ahead and select use grid as the cutting face, and it'll show you an arrow of which direction it's going to cut. Just go ahead, select shapes to cut, this one here, and then go. There's your shape right there. Now I can go ahead, close that tool, apply and close. This is our finished part, and I do the exact same thing I do now as I imported the step file before. I just go ahead. We're going to go ahead and save it. Got to have a job name. Save it as that, and then I'm going to add an operation, but I only want to pick the start layer. Remember, this is the start, and we don't have to reverse this one because we're incorrect. So I click an operation. I make sure I click start, click start cuts instead of in cuts, and then I have the correct consumable selected, my 45 amp. I say okay, and now I can nest a tube. Once again, doesn't matter on the length. I'll make it 15 inches. It doesn't matter. And there you go. There's our cut. Let's go ahead, run the post processor, get our G code. Remember, the G code's the code, the file that we're going to take to the XR. And there you go. There's a G code. Take that, head out to the machine, cut it, and you're done. Now, you would have to go back and modify the grid settings for every time you do this, or recreate the grid and offset it. I think if I was doing this a lot, I would probably use my Inventor because it's easy to go in, change a parameter, export as a step file, and away I go. That's probably the way to go. But if you didn't want to have a separate CAD program, Camelot does do this. Now, I'm looking forward to when I can write the code to do this at the machine. Then you could disregard everything I just showed you once I do that. Anyway, I think that's all I've got for you today. I really appreciate you taking your time out, and I hope you have a good day. Talk to you next time. Goodbye.